There we go. Okay. You didn't even hear anything I said. Bummer. Okay. Well, today we're refreshing our skills here. And yeah, gonna go through other stuff. So what do I have up on the other days? Oh, I have a live for that as well. Does it like still come up as live or does it change? Oh, there it is. Okay. So it does work. All right, never mind. Maybe that link does work. So we'll just go with that. Okay. So what are we doing? Let's get back the link to Python for data analysis from Real Python and get the VS Code going as well. Hopefully it just loads right back up. Shoot. Okay. Yeah, that sucks. So terminal time. And it is 5 analysis projects, and it's Real Python. Data analysis. Oh, actually, we just go to the top and just go there because that's where the venv is. Okay, so just go up into there. So as I was saying to nobody because my microphone wasn't working, that I'm not going to do the music today, so it's going to be kind of bland to listen to, I guess. Not going to really be talking much. I woke up at 12 o'clock. Yeah. Took Hypatia out for a walk. Did my breakfast, sat down, started having breakfast, and was just suddenly very fatigued and tired. And I took a nap. This is around 7:30, 8 o'clock. Took a nap and then I woke up at 10:30. So just feel a lot of fatigue and ache today. Might be feeling the ills of some kind of sickness, but here we are. We're gonna finish the Python for data analysis thing that we started yesterday from Real Python. And figure out which goes to what here. That goes to that. That goes to that. Okay. So, I don't know what I want to do here. We were working on this. So we're gonna get that up and go. Stuff. We explored collecting some data from different sources: CSV, JSON, Parquet, Excel, and learned a little bit that you can't just use straight up pandas to import some of these things. Like the Excel, you need to have OpenPyXL installed. And then with the Parquet, you need to have PyArrow installed. Good to know. Just little technical details. And then also with the HTML, which was really cool. I think that was my favorite part. Think about yesterday's was getting this table from Wikipedia. So we know that like just straight up just default options for this comes back and returns thing. You have to do a little bit of massaging though, because it comes back as a list, I think, um, instead of a data frame. Uh, so with the table, you have to take like the first element of that list, and that's the table. Um, that's the data frame, I guess. Interesting. I didn't really explore that in depth. Um, remind me. There'll probably be something where I'll want to do that, and then I'll do that again. Then we did some data cleansing by renaming the columns to be more Pythonic and just something to uh, go with there. Whew. I don't like the choice of names for IMDb and Rotten Tomatoes. I guess that's like fine, but like I would say rating IMDb or rating Rotten Tomatoes, you know, rating underscore. That's just me. Maybe we could do that and then just do that. We could just go and do that. All right, and then we used masks to change some stuff there. And then the kernel crashed. Interesting. Weird. Okay. Maybe we will. No, maybe not. No, we'll just keep it as that. I don't want to. There's too many things that depends on. I guess I could go and do a control, like a find or something. Yeah, I could do that and then just do the replace. Um, that's fine. Whew. Okay, let me get situated here. Be a minute here before we get started. And also today, I'd like to go through the first chapter of Practical Statistics by Bruce and Bruce. It's Peter and Andrew. Maybe they're brothers. Not sure. Could look that up. Sure, they're on LinkedIn. People who write books are generally on LinkedIn. Might be part of the deal when it comes to writing books for O'Reilly and others. All right. Ooh, buddy. Okay. Yeah. What is going on today? I should do my thing. Put my usual stuff up in the chat, right? Yeah, why not? Let's get my linked. We'll put my LinkedIn on there. I am open to work. Okay, so I don't even remember what I put in there yesterday. I should like save that. Just do similar things every day. Actually, maybe I'll just do that. Let's just do that. So I just need to go to my studio channel dashboard. Let's go back to yesterday's information. So, content from there. Yeah, I'm gonna try not to get a copyright ID claim on here today, and see if that like helps the reach at all or something. And yeah, this should be a 90-day analyst. No, it's not for kids. No. Yeah. We'll do automatic that. Automatic concepts and stuff. That should be fine. At some point, I'll like trim these down, but that is not this day. Um, allow embedding. Let's say no. Video and audio remixing. That's fine. Let's sort by top. Okay, and then what I need to do, I think, is go to the video and view the chat. Live chat replay, or can I get all of the chat? Oh, that sucks. Okay, there it is. Okay. We're gonna copy it, right? No, come on, dude. Stop that. I'm just gonna copy that and we'll just put that's weird. Back that. Oops. All right, that's gonna be that. Okay. Can copy that. And actually, no. You know what? Yeah. So I think if I do this as code, you can just do the copy, right? Yeah, it's just like copy the clipboard, copy the clipboard. There we go. That works. Let's do. Let's actually move all this down. It's gonna be there. And let's put in. Oh gosh. Cut and paste. Okay, that'll be it. Okay, so that should work, right? And then if I go into my other thing, okay, here we go. I'm gonna copy that. We're gonna bring it into the chat here. There we go. And then we're gonna bring this other one into chat. Throw me on LinkedIn. There we go. Got to figure out how to use the API to do that. That would be fun. I don't think you can though. Okay. Oh, maybe you can. Maybe you can connect with a live event and do that. Okay. Just getting started today, so bear with me. Refill up my containers here. All right, we need to listen to something while I'm doing this, so I'm gonna bring a Pocket Cast. I gotta get the other stuff, some other things downloaded onto here. Yeah, definitely. So I'm gonna listen to this. Hey, good game. My gosh, just terrible. I'm gonna try to get like Python podcasts and stuff playing as it's going. So there we go. Let's do the tango actually.
Re-release of her 1989 album.
While we do this,
$19.89. So I love it. We were cutting edge that way. That's right. And so it sounds like, you are still seeing new
I'll
players,
figure this
purchase
out.
copies. That's helping pay for server maintenance.
I'll figure it out.
Yeah, I mean, it's actually a pretty evergreen game, to be honest with you. And every time we go on sale, like, we didn't launch on all our platforms at once. That's the other thing. So we launched on itch, then we launched on Steam, then we launched on PlayStation, then we launched on Xbox during COVID. And every time we launch a new platform, it's a whole new set of players. So
my desk is a bit of a mess right now.
To the Xbox launch during COVID, it was our biggest launch to date.
I remember seeing that. So she's talking about there's this game
about living in the woods, because there was that other
they made about living in the woods, and it was like inspired by Thoreau.
During COVID. So because we've taken, we took so long to launch on each platform, there's like a whole new batch of players there who haven't had the game. And Xbox was our first worldwide, well, I guess you count Steam and itch, but it was our first worldwide console launch. So there's a ton of international players. We get all these letters saying, when will you be porting the game to German? And I'm like, okay, it's me here. It's just me.
How many people have downloaded the game in your estimates?
That's such a great question. I have all the sheets and I've never had time to add it up, but I mean, during COVID, we also were part of all these free, millions have downloaded because we were part of those free packs. So answer is millions. I just don't know how. In fact, that's one of the reasons I freaked out recently. There was that whole thing about Unity and back paying and for units, possibly having to back pay for units download. I was like, no! They backpedal it, so it's all okay now.
Yeah. Wild.
I gave them away to teachers and everyone for free. So yeah, we made the game completely free to teachers and parents, educators at home during COVID. That was the commercial game we gave away.
For that later.
During that time, we were making the modules, so now they're free. We still offer a discount to classrooms for the indie game, but now we just basically say, here's the modules for you if you're teaching with it, and that's easier. It's usually easier in a classroom to not have to download and install anything. But yeah, millions of players, honestly. And we get letters, I swear to God, the range of letters are hilarious. Everything from really older players who are like, I have never played a game since Myst, to bring back to your earlier reference. I've never been interested in playing a game. And this game was so interesting to me. And I now come home every night and look forward to chasing rabbits through the forest and basically living my life in the woods. And that's so beautiful. I've gotten letters from people. It's their first person game that they've ever played. It's so interesting to teach people how to be in an immersive first-person experience. We think, of course, as gamers, that it's completely natural, but it's absurd to think that it's completely natural to be moving one's feet with 4 keys and moving one's head around with a mouse. That is not natural. And when you're walking around the world, you don't think like this as you walk. I'm doing this. But, of course, in 3D worlds, one can move one's head all the way around when walking forwards and backwards, and then you have to break that down and teach it to people who've never done it before. And it's just fascinating. By the way, this is a part of the journey with Night Journey as well, is teaching folks at art galleries who may or may not have ever played a first-person experience how to navigate in a world. And in that case, in the Night Journey, it's a very surreal world with very few visual landmarks. So that one was crazy to have to teach new players how to navigate a 3D immersive experience, right? So we get letters all the way from, this is the first game I've played since Myst and I love it and I just reach out and tell you how much I love it, to I love
3D immersive experience. I mean,
people who are like,
Grand Theft Auto, I guess they missed out on that one.
But
it's weird.
Then we played the game and now I get it, right? And that speaks to me, right? Because I think this book is about the same things we're wrestling with today. He was writing at a time when the speed of life was increasing due to technologies that were taking over, right? So they were dealing with the telegraph, which is like the internet of its time, right? They call it the Victorian internet, right? They were dealing with the telegraph and the train, right? And sort of cables across the ocean being able to tell you what was happening in Europe. And to those people, the speed of information was accelerating so fast. So fast. It's the same way we today.
Okay, I got everything I need, I think.
It's just everyone knows everything all at once.
Okay. Gonna get started on this. So gonna turn off this
we are influencing each other and changing and learning and growing as
podcast thing.
So much faster, right? Well, that's what he's writing about. And he's writing about, if I slowed it down for a minute, what could I learn? What is essential in this world where things are speeding up so quickly? And I think that's really important for us to think about. I know.
Okay. some really interesting discussions on there. I'm not actually. Oh, I should get kept it playing. That's okay. Let's just do this. And it's just it's up here. Could go either way, couldn't it? So much tension. Okay, we got that one in the middle there. Then we have 2 and 2, but then one of the others, right? One of the others, so it's got to be 2 here and then 2 there, but it could go either way. Oh gosh. Okay. So at least one of these has to be a moon, which means this has to be a sun. Then that place is stacked. Great. Okay. Right. Okay, and we're done with that one. Should have seen that before. Oh well, we just figured that out now, though. Okay. The hell are we doing here? Wow. All right, my brain is cooked here. Nothing here, right? Can't get there yet. Here we know that one of these is gonna have to be a sun, so then that has to be a moon, right? So, okay. What does that mean? This one then. You can't, right, you can't have 3 in a row, so there we go, and that places that, and now that has to be that. There we go. Okay, and there, and 2 and 2, and then we have 2 and 2 there. Well, we do have 2, so one of those has to be, well, yeah, can't have 3 in a row either. So there we go with that, and then, I don't know, how does this help up in this corner? Oh, right here. Okay. Wow, my brain's not just not with it yet today. Oh, okay. Got 1, 2, 3, 4, and 5, but 9. Okay. Let's see, we could do the corners there. Those ones. That. Okay. What else? Well, there could do that one as well. That one. And no, that one, I think, yep. And okay. Well, oh, duh. I didn't even see this right across the middle. You have to have that. There we go. And that doesn't, I mean, it doesn't help a ton, but at least we get to see that. Okay, so it's that one and then this one. So then 1 and 1. Huh. I'm not seeing how this helps me in this one. So we know we have 5 there, but then it could be 6 different colors. How does that? I don't know. Oh boy. Um. Okay, so then it can't be there, right? Oh wait, it can be. I don't know what I'm doing here. Oh my goodness. We might just have to do some test cases, I guess. My brain's not with it. Can I narrow this down at all? I don't think I can. So if the purple was there, then you'd have to have red in these two, red and gray in those, so that would be there. The blue, which would mean that would have to be there, and the red would have to be up there. But then that eliminates that, right? So it can't be here because of the right. Right. Can't be there because then you run out of space with the purple there. Okay, so that eliminates that square. Gosh. Too many of them. We could do like one or the other. Does that like help if I do this one? Oh, that one can't be. Okay. Duh, of course, because of the blue. There we go. And how does that help me? So red's going to have to be there. Blue's going to have to be here. And then that's going to have to be there. Oops, I don't know if that... Yeah, it's going to have to be here and then that there. Okay, now we're getting somewhere. Now we're cooking somewhat, I think. And I think we're good there. Wow. What a slow solve for that. Sap, be a patsy, pushover. Could be something that comes out of a tree. Could be to train as energy. No, sap honey. I don't know. Syrup. Honey, sap, chewing gum. Maple? No. I mean, maybe. I don't know. Glue. Sticky? Sticky things. I don't remember. Okay. Loud or hard is soft. Comes from as a flour, or as flour, is to sift. Black powdery substance that soot. Unappetizing looking food. Slop. Okay, there we go. Two-word term for an area by a museum where one might buy souvenirs at a gift shop, right? The gift shop. I'll take you to the gift shop. I'll make you buy it, oi. Cleansing your data with Python, so we'll get back to that. Okay. Ah, my goodness. I should just delete this thing here. I just had a test event. There we go. Okay. Yeah. The year of intentionality. The intention for today. Is to yeah. Intention is to continue. That's it. Just a continuance of yesterday. So let me just set that. Okay. Wow, look at those things I made a while ago. Okay. Scaramouche. Okay. So we're on using Python for data analysis, the data analysis workflow, and that. Let's see, is there anything we need to move over there? Yes, we do. So we do need to move this over too. Notes. Okay. Okay. Okay, so we're going to refresh our Python with stats and let's. Yeah, there's a book by Wes McKinney. I remember that. Yeah. Oh, that would be nice to go through that. However, I was using Python for data science. Oh, it is for data analysis. Okay, that's an old book though, isn't it? I want to actually bring that up. Might as well just bring it up. Data wrangling with pandas, NumPy, and IPython second edition. Yeah, this might be out of date for a lot of concepts. Oh wait, did it say 3.6? Oh gosh. Wow. When was 3.6? Must be like 2015, 27, 2016, 26, updated 2017. Okay. Yeah. There has to be a new one of this, right? Yeah, that's the updated one, and it's third edition, sir. Yeah. All right. Yeah, this one might be out of date. It's not like it's not worth it to go over, to go through. But yeah, might be different. Might be different. I mean, these are just concepts in this practical statistics book. So generally, some of these things don't even need the code. You just need, and in fact, like some of these things I think are in, I think all the code is in R anyway. So, um, my thought was to go through SciPy anyway and do that and correlate like what is what. And actually, I'll probably just mark up this book to indicate what is like how to use it, and then I can just use this as like a reference guide. Like, oh, okay, I need to do blah 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 blah. So what do I use? Oh, I use this other thing. Probably not the fastest way to look stuff up, but generally, I just need to get the idea of what it's what's available. You use. Okay, so let's get started with this. Let's rerun all. We're gonna run all cells and rerun everything. Oh, hopefully I think I did. I think I commented out all of the installs. Yeah, I did the witch python, but that's okay because that's just a shell command. Okay, and then now we can get to the dealing with missing data. I think we were handling financial data. So handling financial columns is what we're up to. We're going to do that. So let's actually do this. Handling financial columns. I should have broken this down. I should have followed along. Actually, I'm just going to go back through and just try to retrace my steps. Understanding the need for a data analysis workflow, setting up your... Okay, so acquiring your data. Yeah, data acquisition. So there wasn't really much from there. But there is reading data from CSV. So we'll put that up on there. And we'll... Oops. And we'll call this... reading data from CSV files. There we go. And then we also have reading data from other sources. And we'll just put that right underneath there, I guess. And let's see. I think that was all it. Cleansing your data with Python. So it was just data cleaning. Data cleansing. Sounds very ominous. We need to cleanse the data. Creating colorful, meaningful column names. Oh, why did I see? I don't know why I thought there was color in there. Creating meaningful column names. Dealing with missing data was under here, right? And so we're not like writing up, we're not writing this notebook up like we would if we were doing a actual report. I'd fill in all of this other information, but I'm just trying to read along and refresh my memory. So yes, the data info code that you ran earlier also revealed to you is a issue. Income, budget, and film length columns all have data types of string, right? They shall be numeric types because strings are of little use for calculations. Similarly, the release column contains the release date is also it should be a date type or date time or something. So first of all, you need to take a look at some of the data in order to learn what the problem is, right? So let's take a look at what we have here. Surprised it doesn't come up with the columns. Huh. And we want to get the first 5 elements of that. We get the income USA, income world, movie budget, film length. There, that looks right. And then, okay, so that's the data that we want to clean. Access multiple columns. You pass a list of column names into the data frames bracket operator. You could also use the index location using data alone as cleaner. Either option will return a data frame containing all the data from those columns. And the 3 financial columns each have $signs in there, so we got to get rid of those and comma separators. While the film length column contains mins for minutes, so you'll need to remove all of this To use the remaining numbers in the analysis, and these additional characters are why the data types are being misinterpreted as strings. But you can make use of the assign method, which I don't. Assign new columns. Yeah, so. Okay. Okay. So then back up, we're going to scroll back up. So the kind of workflow here is kind of interesting. It's not going to, it's just not doing it linearly, I guess, but, okay, whatever. So back up to where we rename the columns, right? Right back up in this cell here. They want us to, right, we're going to do it like this. We're going to make use of this. And then what we'll do, basically encapsulating it in, what do you call them? Parentheses. So I would actually do it differently. So wait, where did the combine first come from? Oh, it's actually down here. Never mind. I'm going off of the wrong thing here. This one. This is the one. This is the one. And we'll put that in that and that out there. So this is what should have been done before. So it should be renamed. So I guess, rename. Stylistic choice. I don't know. People put that. I like to just do it on every single line, see how it is being altered here. And then we could do assign income in the USA is going to be a variable data. And we're going to take that data frame, grab the series for income USA, and replace the a list of things. We're going to replace the $sign and the comma, and we're just going to replace it with that, and then can do regex is true. So this is a regex expression, this square bracket, saying that you're taking a list of characters. So anything matching that, matching one thing from there, is going to be replaced with nothing. It's going to be deleted. Okay, so dot as type. Oops. 64. Okay, I don't know why the linter isn't liking this. Was not closed. I don't see why not. It should be. It ran. It should work. It's closed. What's Pylance is so weird. I don't know if like Pylance is the best thing to use for notebooks in VS Code. So let's It's getting up to noon already. Wow. Okay. So then we have to like rerun that, and then you have to rerun all cells underneath, right? So run all from. I wish it would just like run all from here, right? Can't you run execute cell and all the below ones? Oh, okay. Oh, I did this wrong. Yeah, so I'm not sure what this lambda thing is doing. So where the data is our variable. That's so odd. That is weird, isn't it? Invalid syntax. I don't understand what I'm missing here. Combined first. So let's make sure that we have everything looking correct here. Maybe Pimax is correct here. Maybe you do have to do it like this. No, it's still giving me an error. What could be missing here? So what is the assign? So assign must be giving me something here. So assign, what does assign do? It takes a dictionary of string or callable keywords, keyword args. Temp assign, and then you're assigning to a data frame that. Honestly, I don't think you need the. Why do you need the lambda there? Create the series using a lambda function. But that's you're just you're not creating the series though. Income USA is just the lambda function. It's not the thing itself. It's not the series. Am I missing something? There has to be a note on this. Let's take a look at newest maybe. Okay. Yeah, I don't know. Maybe I have to point this out to them. Oh, you can do it with a lambda function though. Okay. But I think it's not liking the fact that it's just not liking the bracket here. Maybe you can just get rid of it and we'll see if that works. No. Data income. This is weird. Oh, what am I doing? I didn't even put the lambda in there. There it goes. Okay, of course. Oh boy. Okay, so that works. So it does take either a series. So this is good to actually dive into to solidify my understanding of this. So the assign method on a data frame is going to take in a series, either a dictionary, right? Can take a dictionary. Oh wait, no, that's just creating the thing. It can either take a series or it can take a lambda function. You can create multiple columns within the same assign where one of the columns depends on the other, defined with the same assign. Oh, that's interesting. Yeah. I guess they're, wait, is it from Kelvin? Temp Kelvin. Right. Okay. I was gonna say, like, wait a minute. Why would you go from Celsius to Fahrenheit and then Fahrenheit to Celsius? Or yeah, uh, uh, if you already had one of them. But this makes more sense if you have Kelvin converting from from Fahrenheit. Although, I mean, come on, like just go with Celsius and then just like subtract 273 or something like that. Right? Isn't that how you do it? Um or you add 273. Uh yeah, interesting. Huh. Okay, so we looked at the assign operator here. Let's actually take a note. I'm gonna add a stream marker here. Say that we're looking at the assign operator. Or the assign method, whatever. It's best to create the new series using a lambda function. So why is it best? That's an interesting statement. I'm curious what the advantages are there. The lambda function used. Actually, we could ask that, right? Um, yeah, I'm curious because I guess maybe because it's maybe like lazy evaluated. It could be the assign operator with lambdas is like lazily evaluated, maybe versus uh, if you were just doing it, returning the series, it would actually do that calculation, returning the series, and it would use that amount, the size of the series, the in bytes, right, would be stored in memory in cache. So we need to create that in cache and then process it after that. I'm guessing, but I could be wrong. And then I guess as if you put it as a lambda, then it would be kind of lazily evaluated. Well, of course, like yeah, it's not real lazy evaluation. I don't think, not in the Spark sense where you build everything, uh, build your pipeline, and then once you call a an action, it will then trigger all of the running of that. Um, mm. Okay, so I'm going to leave an open question for myself, and that's are lambda expressions lazily evaluated in PD data frame assign in that method? So I'm going to come back to that. I did see some of that stuff, but yeah, I'll come back to that. And I think they might be. I think that might be the advantage. If I formulate my question correctly, then I can like ask in there. So I think I might just ask them on this. Or could also go onto Real Python and do that. That might be something. I might do that. Okay. So I'm going to take a quick break and take Hypatia out for a little afternoon walk, and then maybe grab some lunch. And I'll be back in a little bit, and then we'll continue on building out this project here and handling these financial columns. So not too much done so far. We did just tack on and assign to the, where did it go? Yeah, to the one up there. Okay, so I'll be back soon. Kai. Oakley dokley. Let's figure this out here. Yeah, I think what I'll do is I'll just put. I really don't like Windows. Although I don't know. Is there a Linux OS that has something like this where you can, because this is a kind of nice feature to resize and set things there. Just doesn't always work well with Windows. Okay, so we used the lambda function in lieu of just creating that instead of just doing the series method there. Okay. Yeah, makes sense. I think I have used this in the past. It's been a long time since I've used pandas, really. At least a year, right? Finally, well, like to any like in-depth like cleaning stuff, like here and there. I actually used it a couple of months ago for using working with my crossword clue database. Let's see. Excuse me. Okay, to remove the $ symbol and commas, you pass a regular expression, and that's that, right? So, yeah, okay. That might be something worth going into as well. The regex in Python, of course. Spend a day on that. Define their replacements as just the empty string, right? And also set the regex parameter to true to allow this to be interpreted as a regular expression rather than replacing each of these tokens there. I think that's how that would usually work. I guess no. I guess I think you replace anything with the pair or anything that shows up as that, which of course does not exist in any of the strings that we have. So then making it a regular expression interprets it as the list of things. Any token matching that. Okay, so the result of the lambda function after it, is processed is series with no comma, no $ or anything. So we should be able to run it. So clicking execute cell and below, now we see that our income USA is now in a format that's correct, but it's still a string, I think, right? Oh no, we did cast it as a float 64 after that. So yeah, there we go. Right. Okay, so take another look at the above code and you'll see how it all fits together. You pass assign a parameter named income USA, which references a lambda function. It calculates a series containing the updated content. You assign that series. You assign the series that the lambda produces to a parameter named income USA. Right. That's the series that the lambda produces. Yeah, but it's not actually producing anything. You're just like this is just the lambda function, right? This is just that's just the function that you returned. This isn't actually returning a series, I don't think. That's just the function. Well, assign. Well, yeah, in the verbiage here, in the verbiage, it's you assign the lambda date. You assign, right? You assign the series that the lambda creates to produce a parameter named income USA, or I don't know if that's the accurate way to state that, which tells assign to update the tells assign to update the existing USA income USA column with the new values. Sure. Okay. Go ahead and run this code to remove the offending characters from the income USA column. Don't forget to test your work. Verify that you've made the replacements. Also, remember to verify that the data type of income USA is indeed float 64. Right, when using assign, it's also possible to pass in a column directly. Okay, this causes problems if the income USA column has been changed earlier in the pipeline. These changes won't be available for the calculation of the updated data. By using a lambda function, you force the calculation of a new set of column data based on the most recent version of the data. Don't know what they mean about that. This is if it's been changed earlier in the pipeline. So what I'm gathering from that is that if you have, let's go back here. If you have this type of thing, that they're calling a pipeline here, for this data, James Bond data rename combined first. So this is like a pipeline. Like these are a series of operations that we're performing on this James Bond data. And if you have something that changes the data income USA column earlier in this, that if you tried to reference the column, the changes aren't available. So they're saying that the changes won't be available. So interesting. That's good to know. I'm thinking I should actually highlight this some way. I don't know. I'll move on. I'm gonna keep that in the back of my head about like how I want to take notes on things that I already kind of have a note in my Obsidian note for. So I already have it here. We should maybe highlight the assign. Or actually, I could search for note. Really? There's just too many. Weird. Okay. I don't know why. Oh, I didn't save it as like a call out or anything. Interesting. It doesn't save the notes. Strangely enough. Okay. So we're going to do the same thing, though, for the other thing. I don't know why it didn't pick up those notes. Okay, where would that be then? Where would it be? Where would it be if not there? Value counts, we're going to get into value counts. Okay, so it doesn't save the... Right, okay, so it does not save the notes from there. So I'll actually copy that and then put that into my thing here. We'll actually create this as a actual note. All right, we'll just see that. Reference it from there. I guess that's how I can take notes too, and pin them to specific days. So just did this here. And then on that. Okay. Okay. So there could be interest. So I'm gathering from that statement is that if you change pipeline, if you change that same column earlier in the pipeline, you're not gonna, those changes aren't available to that assign method for some reason. I'm not sure why. I guess it maybe doesn't do it linearly. It doesn't go or sequentially, like one after the other. Or, oh no, I know why. Oh, because what is it called? It has to do with changing something in place versus changing it versus returning the value, right? Versus like returning the data frame. So you could change elements of the data frame in place, which apparently that's not what is happening when you change something in the pipeline. Well, that makes sense. That does make sense because these are returning. At each step, you're returning a data frame in this pipeline. At each step, you're returning. So right here, we did rename on that James Bond data. That returns a data frame. Then we're going to do this combine first, which returns another data frame, and the assign, which is going to return another data frame. So I'm curious why it wouldn't be available to you. Yeah, I'm a little confused about that. Yeah, I don't know. That's interesting. Right, but we gotta do some cleaning here of Income USA. So we did the Income USA, we have to do Income World, movie budget, and then we have to do film length, but we're just going to focus on the financial ones right now, right? The Income World and the movie budget. So what we'll do is go back up and do another assign, right? So we're just going to do lots of assign statements, apparently. And we can just we can copy that. I think it's better if I just do the muscle memory thing, right? Assign. Get some muscle memory. So we want income world, I think. World. We're going to set a lambda for that. And I guess the great thing about this is that lambdas just disappear. This is probably, we probably want to assign that to a function is what I would do. Because yeah, you could assign that to an actual function because we're reusing the same method. I guess it's just a style thing. Income world. We're gonna replace diet. X equals to. Oh, I can format the cell. Curiously enough. I don't know if I like that though. There we go. Put that back. And then as we're gonna cast it as a float 64. Now we're gonna do the same thing. Do budget or movie budget. Movie budget is going to be like data movie budget place using regex, regular expression, and there, and then we can go and we can run all from there, and then we should see that we've cleaned the income world and then movie budget. There we go. So they just did. Oh, they did it in a different thing because you can do it with more than one column. Aha, I did not do this as efficiently as I could. So we could actually just get rid of these assign statements. Put a column in there, a comma in there. And then that should do the same thing. It does the same thing, apparently. Well, let's just verify that it doesn't do the same thing. It does. Okay. Nifty, nifty. Did not know that you could do that multiple columns at a time. A dictionary, strings, or... Yeah, that's weird. Okay, so you can do a list. Callable or string, a dictionary, callable or series. Yeah. Okay. It's blowing my mind here. You basically just have an iterable of lambda objects with three elements, three functions there. So line 12 deals with income world data, 17 deals with the movie budget. As you can see, all three lambdas work in the same way. Once you've made these corrections, remember to test your code by using data.info. Well, we had that down there, right? Oh, I guess we will just verify using data.info, making sure that we have these as Float 64s now for Income USA, Income World, and as movie budget is oh, it's still a string. Good thing we did that, right? Because we have to do as type float 64 and cast it as a string. That probably saved a lot of headaches later. Right, there we go. Great suggestion. Okay, you can fix the remaining. With the currency column data corrected, you can fix the remaining invalid types. Okay, let's do let's do directing invalid data types here. There should be like a an outline or something, isn't it? Oh, there it is, right there. Hmm. Yeah, here we go. Let me just we don't want this like above here. Uh-oh. Where'd it go? Where'd the other stuff go? Uh-oh. I seem to have screwed something up here. So the outline's there, but we can put the outline with the Explorer. Just want to move it up, right? I don't know. Okay. Oh, wait. Yeah, it is up there. Okay. I don't know where I want to put this. Can I put this somewhere else? Up on the side, over there, on the bottom, up on the top. No. Where do you put your uh, outline when working with this? Cool. That's pretty cool. Playing around, learning some stuff here. Okay, so we gotta correct the invalid data types. And we're gonna remove the min string from the film value. So yeah, okay, so remove suffix. Convert that. Okay, so let's open that up. Let's put that up over here. We're gonna use this remove suffix thing here. Remove the offending mins text. You decide to use pandas as string remove theories method. Allows you to remove the string passed to it from the right-hand side of the film length column, and then you can use as in int64 to take care of the data type. Let's see if I can do that on my own. So we're using the same type of thing with the assign, but now what I need to do is to do the film length. Lambda going to be data. Encapsulate this so we can get all the methods there. So we have film length, and we want to do the relieve suffix. And a series string. Right. Okay. So we can just remove the suffix of. Does it need to be space mins or just mins? That's interesting. Do strip Smells a lot amazing. Let's just test this. So we can do that stuff. Let's see if this works. So first of all, just run it, and there's an error. Actually, I forgot a comma. I did forget to get a comma. Thank you. It's so helpful. That's why I should always just put the commas in there. And there is an error. Let's see. What is the error? Series object has no attribute. Remove suffix. So maybe I have to do dot stir. Remove suffix. That does it. Okay, so let's see if that works. And that seems to have worked. We did change the film length to int64 now. Okay. Let's see what their solution was. Okay, so you can get away with just saying that it's mins rather than space mins. Space mins. Well, I'm just confused as to why. So it does remove um remove spaces apparently. Now maybe when you do the casting of the integer, that forces it into being a into being an integer. Maybe it does the stripping of any spaces then. It's just my hunch. Okay. Here we go. So we're gonna just take a look at the head of the data as well. Here floats we have. Yes, okay. So we had financial data. I was going to list the release date column, right? It's a date, and we also have to convert this into date time. So, right, there's invalid date times. So we want to pass that as a to-date time. Pass the series data release date into it, not forgetting to specify a format date. Allow the date values to be interpreted correctly. And here, oh yeah, this month, comma, year is the format string, right? So we need to do, you can use percentage %B followed by a comma and a space to denote the position of the month names. Yeah, percentage %B is the month. So let's take a look at the format strings that we have available to us for this. So locale's full name. Interesting. So it depends on where it is, because you also look, you have German, you have English, US English. Okay. Very powerful library. And then the percentage year is going to get that. Okay. So let's see if I can figure that out. Now what do I have to do though? Oh, we're going to create new columns. Okay, so So you also take the opportunity to create a new column in your data frame named the release year for storing the year of your updated data release date column data. And the code to access this value is data release year.dt.year. You figure that having each year separate may be useful for future analysis and perhaps a future data frame index. Right, and we can do this all in the assign. So interesting. This is a little bit of a different flow, I think, that I've been used to. Like, yeah, like the other flow that that was doing like years ago was loading a lot, like putting a lot of stuff into memory, doing a lot of like sequential updates. But then this one thing is we're just doing it from this one here. Can I do a? I'm gonna add a cell tag. This is gonna be like wrangling. I'm just gonna call this wrangling pipeline. Wrangling pipeline. Interesting. Wonder how that ends up showing up on here. Data cleansing. Yeah. Not sure where it shows up. Okay. Okay. So we can do that all from the assign. So let's do that. So we can add a new one. So what we need to do is to do the release date. And from the release date, we want to make that and the data, take the release date. Now what we're going to have to do is do the DT year, date time, year. Oh wait, that's release year. What am I doing for PD to date time? Can use PD to date time. I think we're gonna have to take a look at that because I think you need to pandas to date time. And then does it return a series? Okay. You can pass a series to it. I think what we're going to do, I think what we have to do is to do this. PD dot. So actually, we can just do it like this. Data, hang on. PD dot date time, or to date time of the series, right? And then we have to pass a format code, right? Format is going to be the comma space start year. See if that works. It does. Now let's go back down to here and see if that worked. So the release date is now a date time. Cool. This is a different flow, so it's taking me a lot slower than I had hoped, but it's very instructive. This is a very good article for me to dive back into pandas after they've made some updates. And I do want to see, like, when has this assign? What's the history of this function here? Let's see. Okay. Yeah. Okay. I guess there has been like just some updates here. It is a matter of style for sure. Because yeah, it hasn't changed. Oncopotamus. Mm, weird. We don't need that, right? Read comments by SA. If you want to look at the same thing. Makes sense. It returns a copy. So it's whether you wish to modify an existing frame or create a new frame, as it was. In particular, there's a new object that has a copy of the original data, but the requested changes the original frame. For example, there, and I suppose you wish to create a new frame. A is everywhere one without destroying TF, and you could use the sign. There you go. Oh, okay. Cool. Cool, cool, cool. Okay. Let's see if I did that right. Oh, I did the okay, so I did the release date one. Now I just need to do the release year, but I'm just gonna hide that for a second because I'm pretty sure I know how to do this now. So release year, and then we're gonna do um we need to do because it's gonna be release data release date now, and it's gonna be um .dt.year. Okay, so I think that's all it is, right? Then maybe you have to. Oh, yeah, you want it as an int64 for sure, right? I don't know how, because otherwise it would. I don't know. Will it? Yeah. Okay. I mean, what would happen if we didn't? We did that. How would it come back as? What's the release year as an int32? Oh. Oh. Well, that's interesting. Why does it come back as an int32? Cool. Let me put a note onto there. Cool. Put comments on all this to make it make more sense, right? Is there a shortcut to run execute cell and below? Should add a shortcut for that probably, right? Because that's going to be something that I use a lot. So you go to the settings and then desired key combination. So get some suggestions here. VS Code. Um, sure, somebody on there. How about Control Shift Enter? Is that something? Alt Enter? Somebody says Alt Enter. Insert a new cell below. Oh, that's a good one too. Alt Enter is probably what I want to use for a lot of them. But I'm looking for execute all. I have to push back doing the practical statistics, honestly. This is taking a while. It's good stuff, though. I do 6 existing commands have this key binding. So maybe you don't want to do that. Okay. Um, 9 existing. 1 existing has that key binding. Debug cell. That's not good. Um, oh, I could copy from here though, right? I could copy the change the win expression and then, oh, come on. And then just copy that and then change the win expression here. Um, and Control Shift Enter executes cell and selects below. Let's see if that works. There we go. Yeah, that's pretty cool. Okay. I think that's the one we want. Just got to copy this and add that to my notes for the day. Yeah. Okay. I should just keep that in there. Notebooks. Hmm. Okay. Just to make sure that I have that. I can actually take a look at this. And, oh, you know what? There we go. Weird. Okay. So, how we doing here? Let's see what we're doing here. I have a stream marker for that. Okay. These are things that I'm gonna like come back to, right? These are things that I'm gonna clip and edit out and make some, like shorts out of or something. Okay. Yeah. The original 27 will have data and then okay. The earnings and film columns have numeric types. Of course, this check wasn't really necessary because, like all good secret agents, you already checked the code as you wrote it. You may also notice that the column order has changed. This has happened as a result of your earlier use of combine first. Column order doesn't matter because you never need to display the data frame when necessary. You can specify a column order using square brackets like that. Right. At this point, made sure nothing is missing from your data. It's all the correct type. Now we're going to fix the inconsistencies with the data underneath here. Having that, I'm just noticing this that having the outline up while I'm doing this makes it a lot easier to uh, decide what my hierarchy is in when selecting, new sections. Which subsection should it be under and that stuff. So we're in data cleansing. It's just, correcting invalid data types. We're just right next to doing all these other transformations. So it just helps me to do that. Go. Updating the movie budget column label earlier, you may notice that its numbers appear small compared to the other financial columns. The reason is that its data is in thousands, whereas the other columns are actual figures. You decided to do something about this because it could cause problems if you compare this data with the other financial columns that you worked on. You might be tempted to write another lambda pass into there using the movie budget parameter. Unfortunately, this won't work because you can't use the same parameter twice in the same function. Really? Okay. That seems like a drawback. Could revisit the movie budget parameter and add functionality to multiply its result by 1,000, or you could create yet another column based on the movie budget column values. Alternatively, you could create a separate assign call. Each of these options will work, but multiplying the existing values is probably the simplest. So go ahead and see if you can multiply the results of your earlier movie budget lambda by 1,000. So, right, why are we doing that? It's in thousands. Well, I mean, yeah, I guess because we're gonna be doing some analysis on that. Um, I don't know. I don't know if that's gonna really matter much. The differences between them are still relatively correct, right? Still relatively the same, I think. Is that true or no? It's just a matter of scaling. Is this even necessary? I don't even know if this is necessary. The movie budget, and then what we're gonna do. Okay, so then how do we do this then? So I think you can, because, and then just multiply it by 1,000, I think. I think that'll work. Yeah, it does. Okay. Full shift enter. Go all the way down to the bottom. And now we have the right movie budget there. Okay, I think that's all we're gonna do there, right? Just multiply the result in this. So this is because of it's like, is it broadcasting or something like that? That's the concept behind um NumPy broadcasting, I think. Yeah, I think that's the idea. Is that when you have a list, multiply it by a scalar, and it's going to do all of these. This is a kind of broadcasting. Scalar B is stretched to become an array of same shape as A, so these shapes are compatible for element by element multiplication. And broadcastable arrays. So you can do addition and it broadcasts those things. So that's kind of the idea, right? Is that you can what does the term pandas broadcasting mean to pandas? There's actually a question that was asked to me on a interview, kind of a like first interview, when I was at Cognizant at trying to secure another role, which I ultimately did not get. But I think I answered it somewhat coherently and cohesively. So broadcasting using a scalar value. So the simplest case is just multiplying by a scalar value. Same expected results with a data frame. That's the idea with that, is that you have a series, and right, this is a result of a series, or the result of this these method chainings is a series, a pandas series, and then you can multiply each element by 1,000 by just using that syntax. Very handy tool, right? It does what you would want it to do very simply, and it, right. Okay, that's the idea with that. Okay, so all financial columns are now in the same use, making comparisons possible. You can now use the techniques that you used earlier to view the values of move budget, confirm that they've adjusted. Right. I've not even gotten to the analysis portion. We're just doing the cleaning. So this takes a while here for me to get back up and running here. As a consequence, you'll often not encounter them until late in your analysis. Indeed, may never notice them at all. Right. So look for typos. So so it's gonna happen where it matters because like the movie titles, those are all unique. You're not gonna have duplicates of those. That's the only other text thing, right? Car manufacturer. Car manufacturer and bond actor are the only two that is gonna really play into effect, right? Maybe someone puts Ashton Martin instead of Aston Martin. So we fixed inconsistencies in data. Now we're gonna fix whatchamacallit. So don't know exactly what we were doing there. Let me see if I can do. Alt enter does that. Okay, and then it creates another markdown cell. Gotta get used to this IDE again, right? So Alt enter is gonna go to the next cell. Okay. I just need to use the keyboard shortcuts. I can't stand using mouse for things when I can take care of it using that. And even when I'm doing this, yeah, I don't even need to use a mouse for switching back and forth. It's just that I have the I have it set up. Maybe I have to rethink that workflow. The triggers for my scene switching in OBS Studio rely on the mouse cursor position. So, I wonder if like you can switch it based on where the window focus is. I'll have to look into that. Keep that in the back of my head here. Okay. We want to correct. Spelling errors. So we're gonna maybe we can like flesh this out a little bit better. So handling financial columns, what we'll do is we'll wonder if you can do a cell reference. So handling financial columns is going to be like that, right? Do you reference cell tags? Okay, yeah, but that's I want to reference to a code cell. That's one workaround. One workaround is to deal with the missing data. Okay. Right. Right. Yeah. Um, I wonder if it does have it there. If there is an ID tag. What is that? Oh, it was insert. So that's not it. Oh, Control K doesn't do anything. Right. Yeah, it's not defined. What are cell tags? Right. Uh, what does it do though? Jupyter slideshow. Interesting. Okay. Okay, I don't know what that means though. Right. I mean, I can create the references in there. So what I want to do, actually, I think what I can do is the section. Oh gosh, why did I do that? Okay. I think. Yeah, I think that's it. I think that'll work. Add it to wrangling. So you collapse. Maybe we can't do like cold folding. Huh, interesting. Okay. Weirdy McWeirdy. There we go. So that does work if I do it to there, and then so I can just like copy and paste that one. So, oh my gosh, come on. Keep using the wrong thing. So let's do go enter, and then we'll do this. We'll add that to correcting invalid data types. We'll add code to deal with that. So we'll incorrect data types. Invalid data types. What ones did we use for that? It was the date, right? And then the date time. That was it. Right. That's so dumb. I am not a very smart man. So we'll do it from the sign, right? So that should be enough for me to indicate what this is. Code from there, code from there, code from there. That's fine. Indicates that there's, gaps in there, so it's fine. Do the same thing for this, I think, from the data. Just do it from assign that. Do that, that's fine. Yeah, and then fixing inconsistencies in data is the oh, that's weird. What, I just have the date stuff there? Film length and release date. Okay, and then I did add the release year onto there as well. There we go. Okay, so this is, I think this is a good way to go about this. And then can correct invalid data types, fix inconsistencies, and you do highlighting. You do highlight like that. Yeah. It depends. Well, Obsidian does it. Someone says Obsidian. I thought someone said Obsidian. Right. Okay, so there are some that do it, but there are others that don't. We're not sure if this is going to be the one that does it or not. It is not. And of course, it's not going to do it inside of that. Maybe it's like... No, because... Yeah, it's not going to do it. So basically what we're fixing here is... add some of the stuff to that. I might add this. I might just like put this up on GitHub or something like that. Do that. Yeah, I don't know what to do with this here. Okay, so we can't do markdown highlighting in there. Just trying to understand. Like it's going to be slow going at first here. This is just the first week that I'm getting my skills back. You know, so it's gonna be slow going. Gonna be slow going. So to check on correcting spelling errors, what we're gonna do is to find bond actor value counts, and then like we'll probably also look at the other ones as well. So it looks like there's one with Roger Moore where the Moore is capitalized. It's in all caps. George Lazenby, that's an I didn't even know that guy was a thing there. So Sean Connery, there's one. Of course, that's probably the one that's, without even knowing, that's probably the wrong spelling because of the other ones. You know, I guess popularity wins, but you know we can do our research and confirm that. Roger Moore, George Lazenby. Is that even a really? Oh, isn't he a hunk? Began his professional career as a modeling actor when he was cast to replace the original Bond actor Sean Connery, playing the character in On Her Majesty's Secret Service in 1969. Since he appeared in only one film, Lazenby's tenure as Bond is the shortest among the actors in the series, with Timothy Dalton, I guess, being in second because he's had 3, Pierce Brosnan with 4, and Daniel Craig has gotten up there into the top 3 amongst Roger Moore and Sean Connery. Okay, I wonder if he's going to do any more. I don't think he is, right? I thought they were talking about having a new Bond. Okay, did not know about him. It's a good trivia. Good bit of trivia there. Okay, so how are we going to change the Bond actors? So we have to first we have to identify the ones that are misspelled, right? And then we have to change them, right? And so we need to find them when they're like this. So I think we could do a replace on all. That's kind of like a little excessive, or we can like find the location where that is. This is a very small data set. I mean, you can just go over all of them, but I wonder what they're going to suggest for this string dot replace. Okay, yeah, they are going to just do a straight up replace with that. Yeah. So only need to pass it in the original string and the string that you want to replace it with. And in this case, you can replace both typos at the same time by chaining 2 calls of that string dot replace in the above. So I guess, okay, so what we can do is we can go back up to here and do in the assign. So in assign, since we haven't touched the Bond actor yet, we can do and just do dot stir dot replace for the misspellings, which I think are Sean Connery, or just, yeah, Sean Connery with Sean Connery, right? And then, I mean, these are just manual updates, and then we can string another one, replace Roger Moore, more, or we can just replace more with more. And I think that's going to do it. We'll see if that works. And now we have 8 for Roger Moore and 6 for Sean Connery and no others. That seems to have done the trick. We'll go back up and copy this little snippet of code, and we will add that to, actually, let's copy that, and then we'll just go back down. So fixing spelling errors, correcting spelling errors, we're going to add right. Okay. So fixing the actors' names, I'm gonna have that. So they're going Sean into Sean. I just did the whole name because just in case we need to ever run this again. And there actually is someone named Sean. and they're spelling it SHAAWN. Maybe. I'm just thinking in the future. But with more being capitalized, that is pretty generic. You just don't want it capitalized. You want it to be in title case. So, yeah, that's fine. I think you can also do stir.title case. I think that would work, actually. I wonder. Let me try that. Let me try. I'm curious. No. What is the, how do you do string title case? Is it just stir.title? Maybe it's just stir.title. That works. And then, so where am I? There. So let's go. Oh, it's a method then. Keisha. Okay. Bond actor. So that doesn't, it did work. It just didn't give me what I wanted. So because stir.title is a thing, so stir.replace, it's actually, it's going to be PD. Oh. Maybe it's just a suggestion that hasn't been put on there. Maybe. Oh, that does work. Okay, never mind. So it does work. I just actually have to call the method. So before I wasn't calling the method. It was just without the parentheses there. It's just returning the method itself and not the result of running the method. It didn't execute it. So do this, go like that, or stir dot to replace that. So we're going to do that. I'm just going to copy that line. There we go. And that works for us then. That replaces that. All instances of Sean to Sean. Why don't you analyze the car manufacturer's names and see if you can spot any typos? If there are any, use the techniques shown above to fix them. So I do want to take a look at the cars as well. So I'll do car makes. Let's go from there. So so what do we do? We're doing car manufacturer. So it's not makes, it's manufacturer. Value counts. Now we can see this. So we do have, what the heck is Bajaj? Is that a car? Oops. Yeah, apparently so. So what movie was that in? Interesting. See if there's any misspellings. There are. It's Aston Martin with an I instead of an O in Aston. And I think that's the only one, unless AMC is a different thing. We could research all of these and see if they basically are the same thing. Or I don't know if that even matters. Probably not. So the only misspelling that matters is Aston Martin. So we can do the same thing and just replace Aston Tin with Aston. So go back up to here. We're just gonna car manufacturer is the lambda data, and then car manufacturer stir dot replace, and we're gonna do Aston Martin, and we're gonna replace with Aston Martin. And yeah, and then that should work. And let's just copy that for now, and then we'll paste it into our handy dandy thing. Although, wait a minute, what just happened? We forgot a comma. Ooh. Always with the forgetting of the commas. Apologies for my sneezies. Apologies for my sneezies. Okay, I think that's good then. I think that's what we're doing. Right, and we see that there were 2 from there, so we went from 8 to the other one. So we just update that to be replace Aston with Aston, and I don't know. Maybe there's going to be a car, ASTIN, and it's a knockoff of Aston Martin. I don't know. So, but for now, I think, I don't know, it's going to be, yeah, maybe there's a car that comes out called an Aston Matrone or something like that. That's not gonna. This is gonna change that, and maybe not. I don't know. Just practicing forward thinking when it comes to doing this, just as a practice. With the typos fixed next, you'll see if you can find any suspicious looking data, checking for individual or invalid outliers. Ooh, okay, and we're still in the cleaning phase, right? So we're gonna check for invalid outliers. So above, we're gonna put something in here. So markdown cell. And then underneath that, we're gonna do a Python cell. Okay. Not entirely sure what we're doing here. Film length. There, bond kills are also something. Shouldn't we look at those? Why not look at all of them? Why not look at all of the other int ones? Yeah, why can't we just do all of them? Can't we just look at all of them? So we're looking specifically at these 2, but like, why not look at just data.describe? I mean, it's a little much, right? It's a little big, but It's fine. Do it this way. So release date. We actually have a right. Okay, and then we can see the standard deviation of some things. Of the numerical values here. Release year. Get an idea of spread. So it's a little harder to read with this because it doesn't freeze the left column. So we could just get rid of the movie date. I don't know why the date is considered numerical. Okay. We could take a closer look at the scribe here and see if we can include or exclude uh yeah, I don't know. I don't know how to exclude dates from there. A list like of date types. Um, yeah, date time spelled like that, daytime object. Pretty sure that we can do it that way. Can we not do it that way? No, that doesn't work. What let's just Google for it. Let's see. What are the data types anyway? Date time 64. So that's what, okay, so we can just like copy that, I think. Date time 64 seconds. Should I do that? No? Okay, I don't know how to do it. Wait, did it? I think it might have. Top and frequency. Okay, that's weird. I'm going in depth on this because I really want to make sure that I understand um, the power of this describe. Um, before really going forward. So they already identified, I think, some outliers. So you can go one by one. Mean standard deviation. So how are they locating outliers? Maybe with the max. Max and mins. Oh, I do see something in the martinis consumed. It is like -6. That can't be. What is he like? He gives away martinis? He throws them up? He threw up 6 martinis? It's negative number of martinis. With some appletinis. Oh, I gotta do my Khan Academy stuff too. Um, hmm. I need to take a break. I've been going for a little bit here. And, need to take a little bit of a break here. Set of statistical measures relating to the series or groups numerical values. The data frame that you call it on, these also reveal some probable errors. So looking at the film length column, I'm going to look at on the side here. 1200 is the max. That's got to be wrong, right? Most movies are 130 more. Yeah, and the mean has been skewed by the maximum, which has a whopping, uh, whopping 1200. And what was the mean? 60. Yeah. So, yep. That's a good point. So that like even though most of the median is 130, right? So the median's 130. And yet the mean is being tugged really hard by something, right? So we know that there's some skew. How big, right? And or where is it coming from? It's coming from this. There's got to be an error here. Maybe that was just a typo. Maybe it's supposed to be 120. We're gonna have to like find out which one that is, and then fix it. So let's just go with what they say. Looking at the film length column, the quartile figures reveal that most movies are around 130 minutes long. All right, I already did this. Okay. If the mean is almost 100%. So depending on the nature of the analysis, you probably want to recheck your source to find out if this maximum value is indeed correct. In this scenario, having a movie lasting 20 hours clearly indicates a typo. Well, I mean, I don't know. It's an epic Bond film. After verifying your original data set, you find 120 to be the correct value. So the original data set was from Kaggle. What? I mean, what do you mean? How'd you find that out? Interesting that there have been like spiking downloads January 5th. Not many. So small, but see if there's like last 6 months. It's always just been very small. Okay. I don't know where they got that from. I guess like, well, I don't know. I don't want to go through that much. I could go on IMDb, but I need to know the name of the movie. I don't really want to do that right now. It's going to be lazy. Turning next to the number of martinis that Bond drank, you see that -6 doesn't make sense. So as before you recheck the source and find that should be that. Right, so we can just use the replace method again and just build out that pipeline, right, with that assign. So let's go back to the wrangling here. The wrangling pipeline, and we can do Martinez consumed. Data, and then we can do and we can just use the replace method with -6 and replace it with 6. I'll update the martini fingers. And you can use a similar technique for the film duration, so we can do that with appears to be an error somewhere along here. Yeah, it's right there. There it is. Need the comma. Keep forgetting the comma, man. Gotta remember that we gotta put a comma at the end. Man, that's messed up. She don't need a comma. So film length is repeated. It's good. That's a very good. That might be an update to the errors there. There we go. Let's do that and go back down to the bottom. And now we see that the maximum is 163, which makes more sense, and the maximum is 6. Martini is consumed, and the minimum is 0. Just a sane number of martinis to consume. Are there anything else? Is there anything else? I guess that they already, like, we're just going off of what they did, but like we would have to go through each and every one, make sure that nothing is really that crazy. Movie budget. The mean is what? That, oh wow. I think there's something wrong with the movie budget. $67 billion? That has to be wrong. The maximum, there has to be something wrong with the maximum of the movie budget because 275 billion? There's no way. Really? Oh, it's a million. What am I doing? I don't know orders. I don't know my orders of magnitude. What is wrong with me? Okay. So, but why does it say, okay, so the average, the mean is, okay, that makes sense. Okay. Oh my gosh. I'm not a smart man sometimes. Okay. Spectre exceeded 245 million. Apparently, they have this as 275. Yeah. I don't think anything else looks crazy. Car manufacturer. So we can. There we go. Oh, because it does do. Okay, can you just like include categorical column or interesting. It's weird. Yeah, okay, so that's what we did. Getting a little bit lazy, but I do want to make sure that I like document this so that when I okay. I'm hungry, honestly. I need some food. I'm starting to get a headache from the lack of food. Okay. Mark down. We don't need are we up to that? We're gonna remove duplicate data. Okay. When we come back, I will do removing of the duplicates. So we'll handle that. How much more do we have? We have storing cleanse data. So we'll also, I'll just do that right now. And then we're going to store the cleanse data in some way. So that's what we'll do when I come back. We still got a lot ahead of us. Well, actually, it's not too much more. It's just data analysis and then communicate. So that's not going to be too much. But we'll do the removing of the duplicate data and still, oh, well, we'll do the Khan Academy as well. So I should get that up and running as well. So we'll do Khan Academy things, and then I'll do using Python for data analysis. Then we'll come back and we'll do practical statistics, getting into that. And maybe I'll use this data set in some way to do that. I'm not sure. Yeah, I just need some food. So I'll be back in about an hour. I think. All right, so we're back. We're gonna redo the thing we did yesterday, right, with the geometric distributions. So now we know that. I want to actually create a note in my Obsidian. I'm going to actually break this out here. Do that. And then so let me see if I can search through here. Geometric distribution. No, we don't have that yet. So let's go ahead, create that note. Whoops. Distribuzione. So Italian. And what we have is we have like math, right? Math and statistics. And this is actually in like probability, isn't it? Ooh, okay. Probability. I used to have a probability teacher in undergrad. One of my friends would always repeat his the way that he would pronounce probability. He would like elide over the IT, and it would sound like probilly. So, it was good enough for him. It's good enough for me. So I may not be able to pronounce the word, even though he was an expert at probability. No, even the best have some difficulty saying the word, you know. Okay, so what we know about the geometric distribution, we know that the mean is oops. Or it should define it, right? There should be a definition somewhere. So we should try to understand the definition. What we know, though, is that the mean is going to be 1 over some value p. That's the probability of an event occurring, right? And then the geometric distribution is so I guess you usually say like x is the number of events it depends on how you define it, right? It's number of events before the first, or like the number of trials before the event occurring, basically. I don't know. And then the variance there, right? And we know the variance, and then we know the whatchamacallit. So we could actually, so let me see, because yeah, 1 over p, I think I really want to do this as a frac. Is it backslash frac? Yeah. Oh, I wish I had the auto completion of some other things, right? Wait, can I get that? In the editor, is there any other delimiters that we can auto pair brackets? Oh gosh. Because it doesn't pair the other ones for me, right? Oh, it does. It just doesn't do it inside of the LaTeX context. Okay. We don't need that. We just need that. Then the variance is going to be 1 minus p divided by p squared, right? Yeah, I don't like the way that looks, but it's I guess okay. I think you can do it like this to do it in display. No? How do you just do it in display? I think this is in a separate thing though. Yeah, that's wrong. Oh gosh, come on. Oh, I don't want that. I want to show it in whatchamacallit, in oh wait, isn't there larger fractions? It's nice frac, but I think you need dfrac, nice frac, display style. Number 1. Oh, right, those are variables. Okay. I don't think we have access to nice frac here. No. Display fraction. Defrac. There we go. Ah. Ah, 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 ah. Ha, 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 ha. Ha, 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 ha. Ha, ha, ha. Ha, 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 ha. Defrac. That's what we want. Now, the mean and the variance. We know the mean and the variance, right? Number of trials before that occurring. So then we know that and then we know the probability of x equaling k is equal to 1 minus p to the k minus 1 times p, right? I think. Yeah. Right. And to do the proof, I mean, it's just the geometric series, basically. And then that just like all comes out to being 1 over p. You take the infinite sum of all these little probabilities from 0 to k, or from 1. Oh, right, from 1, because then that will be when k is equal to 1, then that first term just goes to 1. 1 times p is p. So right, so from 1 to infinity. Okay. And the mean number of weddings. So let's get the calculator. 43% of weddings Jared plans. A friend or family member officiates the wedding instead of a professional. You want W to be the number of weddings Jared plans to reach a wedding where the number Jared plans to reach a wedding where professional. The number of weddings where Jared plans to reach a wedding before where, okay. The officiator of each wedding is independent. Okay. It's an important assumption, right? Okay, so we want 0.56. And we want the reciprocal of that. So, oh gosh, I really don't like this. I'm getting rid of that one. Let's use RLCalc. I could use Python as well. Be nice to use that. So we want 1 divided by 0.56, which is going to be 1.7 or 1.8 weddings. And then the standard deviation is going to be the square root of that 1 minus p over p squared. So, yeah, so our p is, we're going to define p as being 0.56. So 1 minus p is, of course, 0.43. We divide that by p squared, which is that, and we're going to square it, and we're going to get 1.4. Square root, though, remember, we got to take a square root. Okay. Take a square root of that, and it's 1.17 or 1.2. Yes. Okay. Got that one right. Let's continue this. In the US, 21% of households use a clothesline to dry their laundry. Capuchin would like to survey households that use a clothesline, so she plans to conduct randomly selected US households until she finds one to use. Actually, let me find out. Interesting. Okay. Gonna have to look into that. 21% of households use a clothesline, and we want F to be the number of households contacted before. Well, contacted to reach the first household that uses a clothesline. Mean and standard deviation of F. Randomly selected U.S. households and church finds one that. Oh my gosh. Having a difficult time reading this because I'm reading questions. I just like my brain just shuts down. So I just gotta take a deep breath and read through. There's too many words to express this, right? It's such a simple idea. 21% of households use a clothesline to dry their laundry. Capucine would like to survey households that use a clothesline, so she plans to contact randomly selected U.S. households until she finds ones that use one. Okay. So 21% use a clothesline, and we want to find the number of households before, or number of households contacted to when she finds the whatchamacallit. Okay. So it's going to be 1 divided by 0.21. 4.8, and then our standard deviation is going to be 0.21 divided by 0.89 or 0.79 squared. So we've got to square that part. And then the result, we have to take the square root of. There we go. So we could also just take the square root of 1 minus p and then divide it by p to get the standard deviation. 0.6 households? No? Where did I go wrong? Wait a minute. So if I do 1 minus 0.21, you have 79. Oh, I didn't square it. Oh, I did the wrong thing. Oh, duh. I did it backwards. Oh my gosh, my brain is so dumb. 0.79, right? And we want to take the square root of 0.79. Take square root. And then what we want to do is divide by 0.21. And then that is that makes more sense, right? There we go. My goodness, I'm going to be stuck on this like all week. Yeah, okay. Giorgio has determined that 19% of the thousands of photos of rainbows posted to a website show double rainbows. Let R be the number of rainbow photos Giorgio looks at until a photo shows a double rainbow. Oh, images in each photo are independent. Mean and standard deviation. So the mean. Okay, 19% are double rainbowed. Let's clear. Can I clear the history? Date calculation. Look at that. What's programmer? Bit shift. Oh my gosh. Awesome. What? Windows calculator is so amazing. You have a graphing calculator on here now? What is going on with Windows calculator? There's so much going on. You have data as well. Wait a minute. What does that mean? Oh, converter. From a nibble to a there. Okay, that's interesting. Currency converter, speed, power, kilowatts to horsepower. It's a scientific physical calculator there. Look at that. The trigonometry functions. It's a pretty handy dandy calculator here. Okay. Okay. 1 divided by 0.19 is going to be 5.2, 5.3, because we're going to round it up. And then the mean and standard deviation. I could just do this in like Python and have it spit out the answer for me, right? And as a matter of fact, I might do that. I think that's probably what I should do. So we know theoretically how to get it, right? So what I want to do, we need to do 0.71, right? And take the square root of that, and then divide that by p, which was 0.19. It's 4.4. No? What did I do wrong? 19% show a double rainbow. And you want R to be the number it looks at until the photo shows a double rainbow. Okay, right, so we want 1 divided by 0.21, or 1 divided by 0.19. Yeah, okay. Oh, it's 0.81, and then we take square root, is going to be 0.09, or 0.9. It's going to be 0.9 divided by 19. It's 4.7. Oh my gosh, I'm cheating. I'm going to cheat. All right, so we made our note, and we're just going to keep that. Put that into our notes. I'll deal with that later. Yeah. I guess we could like. Right. I don't know what format we want to keep this at, but we'll do that. So how do I do this in Python? I think what I'm going to do, bring up a terminal. And I know I have IPython installed under the well, under here, right? So we have the vend there. So we're going to source there it is. Okay, so if we do a pip freeze, see what we have. Pretty sure that we have whatchamacallit. Oh, I should have started using UV, but okay, we'll do that maybe once we start doing some actual projects. I'll start learning how to do that. So I want to use IPython. I think first, before I do that, I want to make sure that I get the requirements updated. Requirements text. And then I'm going to do IPython interactive. There it is. What was that warning if you encounter problems? Okay, inside here, I can do pip install scipy, I think. Use the magic pip. Okay, it may not work as intended. It is going to the right place, though, for the site packages, though. Okay. I think it's in scipy. Geometric distribution. We can like link to that from there, right? So the geometric scipy, that's okay. Interesting, because there we go. What's the F? Yeah. Unstable development version 1.15. Okay. So we're going to copy the link to that, and then we're going to Python links to there, I think. SciPy.stats import geom. I guess we need NumPy imported as well for some reason. I don't know why. No, okay, so here's the methods. That's kind of what I want to get at. I want to just get that method. Nice. Okay. There we go. Nice. Nicely done there. Okay. Then we have the SciPy, we have the methods, and then we have how to bring it in. And the methods that you use from there are there. So we have that. I like that. I like that a lot. Okay, so we're going to bring that down over. We'll bring that to, actually, let's put that up there and then we'll put this down here. There we go. Right? That works. Okay. Yeah. There we go. Okay, so we want to use Python. So I'm going to exit out of. Actually, so we have SciPy installed. So we want to from SciPy stats import geom. Let's hope that it works. Taking a while. Okay. And then we can use geom dot. Isn't there some? Yeah, there it is. Okay. CDF, we want to find the mean, right? And what do we get from here? So the mean is going to have, it's going to take P, and loc, I guess, is the, I don't know what that means. Some kind of shifting thing or something. Yeah, I don't know. I'm going to have to look that up. Oh, you could do stats. Kurtosis and or kurtosis. We could do stats. Get the variance. Standard deviation as well. I could just do the mean of 0.19, right? I just want to test to make sure that this is right. And then geom of STD of 0.19. Let's see if that's there. 5.26, right? And then 4.736, and that's correct. Okay, seems to be right. We're going to go on to the next question. Jamie is conducting inventory at a public library. To verify that each item from the catalog is in its correct location at any given time, 97% of the items are checked into the library B is the number of items that Jeremy verifies to reach the first item that is checked out. Okay. So 3% are going to be checked out. That she verifies to reach the first item that is checked out. Assume that each item's checked out status is independent. Right. So we just go ahead and enter in this. So what I want to do. Okay. 0.03, 0.03, and then we'll see we got MP afloat, so it's 33. And a third. And it's 32.8. So there we go. And we're going to show the summary from right there. That was it? That was the only one? I thought we did 4. Can I do it again? Okay. Tomorrow we'll do this again. And then we'll go and we'll do the same type of thing. Be good practice. Exit out, exit out. Okay, geometric distribution. We got that all settled. Then we got a note for that. Bigger equation. We learned how to do bigger equation with dfrac. You know, that's a good one. Okay. I might need to take a quick break again just for bio. And when I return, we're going to do the removing of the duplicates. And let's get started with that, actually. We want to put underneath the Python cell duplicated. Yep. Duplicated equals false. Well, I mean, okay, 4 by 13. I don't, what? So these are duplicates, apparently. Okay, I see. This was probably the one with the Roger Moore thing, right? Well, maybe not, because the time that Timothy Dalton one shows up again. Maybe that was the one with the martinis. Nope. It was the one with the budget. No. Film length, no. I guess it was just a duplicate. Okay. That's interesting. So we can check for duplicates this way. Data.duplicated keep equals false. It used to be, yeah. I don't know when they introduced that. That's a new thing, I think. Keep equals false. All the duplicates are true. Okay, that's what happens when you do that. All right, they're going to explain that, but that's interesting. It's kind of right. So we check for duplicates after, right? We have to check for duplicates after we do some massaging. It's a good note to make there. After we do some data cleaning, you got to check for duplicates then. Return a Boolean series. Pass this Boolean series to data.lock, the index or the label location, label locator. Okay, and then, yeah, I always did like drop duplicates, right? Drop duplicates method on the data frame that you're building up. As its name suggests, this method will look through the data frame and remove any duplicates that it finds leaving only one, right, to re-index the frame. Sequentially, you set ignore index equals true. See if you can figure out where to insert drop duplicates into your code. You don't use a lambda, but duplicates are removed after the call to assign has been finished, right? So we sign everything and then we do the drop duplicates. So we're going to so after here. Drop duplicates. And then what we need to do is to ignore the index. And okay. Then we can run this all again. Go down to the bottom, come back up here. There are no more duplicates now. And we see that that we took care of that. So we added um, there we go. That's where we do that. Now successfully identified several flaws with your data, used various techniques to cleanse them. Keep in mind that if your analysis highlights new flaws, then you may need to revisit the cleansing phase once more. On this occasion, this isn't necessary. With your data suitably cleansed, you might be tempted to jump in and start your analysis. A very important task that you have to do, storing it. Okay, so this should just be easy. Let's see. Yeah, let's go out there. You've learned that you should save your cleansed data frame to a fresh file. Other analysts can then use this to save the trouble of having to re-cleanse the same issues once more, but you're also allowing access to the original file in case they need it for reference. The toCSV method allows you to perform this good practice. So data.toCSV, and we're going to do James data cleansed. Okay, and then what we're going to do is index equals false. And actually what I want to do is to set this from here, and then we're going to go into the output. We could just put it in data. I think just putting it in data is fine. Because we can have the clean data and then we can have the other thing in there. There we go. So now we have a cleansed CSV for our data. And then you write your cleansed data frame out to a CSV file named James Bond data cleansed.csv by setting index equals false. You're not writing the index, only the pure data. This file will be useful for future analysts. And earlier you saw how you can source data from a variety of different file types, including Excel spreadsheets and JSON. You won't be surprised to learn that Pandas also allows you to write data frame content back out to these files, right? So we can do Parquet as well, right? We can do do Excel. Excel SX. into Parquet, I guess. You do an index equals false as well. Data.to Parquet to clipboard. We're going to do an index false for that one as well. There's an error. So what do we need for this? So format writer. Oh, of course. Okay, cool. And then there we go. We have a Parquet file, as well as some other Excel files. So we can deal with Parquet, we can deal with Excel, we can deal with JSON as well. We can do JSON data as well, JSON bond data to JSON. Okay, we can do that. Okay. And now we have JSON file as well, so we can actually open that up. Oh, get rid of that one. It's going to show up as that it is that, but just delete that. Cool. Parquet isn't supported by all tools, of course. Great format for storing your intermediate files because they're compressed and support the different data types we are working with. Its biggest disadvantage is that Parquet is not supported by all tools. So before moving on, take a moment to reflect on what you've achieved up to this point. You've cleansed your data such that it's now structurally sound with nothing missing, no duplicates, and no invalid data types or outliers. You've also removed spelling errors and inconsistencies between similar data values. So your great effort so far not only allows you to analyze your data with confidence, but by highlighting these issues, it may be possible for you to revisit the data source and fix those issues there as well. Indeed, you can perhaps prevent similar issues from reappearing in the future if you've highlighted a flaw in the process for acquiring the original data. Data cleansing really is worth putting time and effort into, and you've reached an important milestone. Now that you've tidied up and stored your data, it's time to move on to the main part of the mission. It's time to start meeting the objectives, right? So I'm going to take a quick break, come back to this. We're going to talk about descriptive, diagnostic, predictive, and prescriptive analytics. Okay. Yeah. So I'll update our note on data analysis as well. So I think I'll get that. I'm going to open in a new window. Open to the right, shift to create, open in a new tab, open in a new window. Open to the right, control alt, shift to create. Yeah. Guess we just want it on the right and then we're going to bounce it out. Then we're going to take a look at it. We're going to update our note on data analysis into here, into our note on data analysis. Okay. There we go. We're just fleshing out this whole idea here. It's just going to take little by little, going to take a little bit of time. So incremental improvements day after day. Okay, going to make some notes. Performing data analysis using Python. So you should just flesh out this whole page as this. So we have definitions. I'm going to do tags. We're going to do statistics. Yeah, data science statistics. Or, you know what? Data analytics. Data analytics. Okay. And so we're going to go with the 4 major types of analysis. So we're going to have descriptive analysis. So that's going to be a definition here. And we're going to do a definition. And we're going to say uses previous data to explain what's happened in the past and common examples. And then so we can do, oops. You just say common examples include, let's do example is identifying sales trends or or customer behavior, and we can always flesh this out a little more. Do some examples there. And the next one is going to be diagnostic. Does it like say definition? It does say definition. We'll just put definition there. Yeah, actually, diagnostic analysis. Tries to find out why events happened. And we could do examples here as why did the sales trend occur? Why exactly the customers do what they did? And then we have predictive analytics, which I have done a little bit of with at Lambda School. This is builds on descriptive builds on descriptive analysis and diagnostic analysis we're going to take this source from there, and then we're gonna, so we're sourcing that. And what might happen in the future, and then so examples could be what do we expect future sales trends to do? What do we expect? I need to fix these callouts. I don't like the way that they're padded and spaced. Okay, and then we have prescriptive analysis is which action should we take, right? So we build, so I think it's just going to builds on diagnostic and uses techniques to try to predict. Descriptive analytics. Future strategy. There we go. And for example, you might want to implement measures to prevent sales trends from dipping, maybe. Suggest measures, right? Suggest measures to prevent sales trends from falling. And sales trends from falling and customers to leave elsewhere. Okay. I need to fix those callouts. I don't like how big of a padding there is, and the spacing between this and the list is a little too much. But we'll get to that. Okay. In this tutorial, you'll use Python to perform some descriptive analysis techniques. And we'll use some regression. Oh my goodness, it is 4:30 already. We're not finished with this yet. Can you believe that? Okay. It has been a lot, right? We've covered a lot of stuff, a lot of ground here. I did want to see like if you can I don't think this is possible. That's what I've been trying to find out. They're not shareable at this time, as of last year. For the last 8 months, 9 months. Multiple accounts. Yeah, that's what I would like to. I guess I don't know. Sucks that they're not shareable. Honestly. Oh well, we still got a lot to do here. Let's get through this. Purpose of the analysis stage is the workflow diagram that we saw earlier, right? There it is. This part to possibly recleanse and then do more analysis, or we can just go right to communicating our findings. And let's go into data analysis here. Okay, so we need scikit-learn for this. Okay, cool. We did get matplotlib, but we didn't do the scikit-learn. Probably your conclusions that others would be interested in if you've ever challenged on how you arrived at them. You have the source data to support your claims. Support the complete the remainder of this tutorial. We need both matplotlib and scikit-learn, so we can do that. We do have scikit-learn all the way already installed. Yeah, so we can just go right into here. Right? We have the right Python. What I'm going to do is do install, and we're going to do scikit. Here we go. Okay. I don't know why you would use this. There's stats models and stuff you can use as well. It's SciPy, so I don't know why scikit-learn is needed. Okay. We'll do regression analysis. Matplotlib library to do this. You'll use the plotting capabilities of that. Descriptive analysis, diagnostic analysis, and predictive analysis, and prescriptive analysis. Okay. So there's our source for that. We actually also have downloaded the source for this as well. So yeah. I always cite my sources. I just want to make sure that I'm not claiming that these are my ideas. Right, so we'll do regression analysis. Oops. I don't know why. I have that zoomed in, I think, because I wanted it on screen. I think I'm going to go with this, though, and then, because I can always just zoom in. You know, I can always just zoom in. This is comfortable. I like that. Just makes everything else look better, I think. The size of everything is a little bit better. Okay. It's going to take a while for you joblib scikit-learn. Thread pool CTL control, thread pool control. Okay. Go. So of course we have scikit-learn and matplotlib, Python plotting and matplotlib. This is kind of old from 2018. There's been a lot of updates to matplotlib, but I guess the basics are still the same. This is pretty good to go by. This might be something that I just go over. Who did this? Was it just Dan? That was Brad Sloan. I think I'm gonna like just save that data viz. Okay. Save this works bar. It's gonna be our libraries to deal with. Should go back to the pandas homepage documentation. Just save that. I could like save that into docs or something. So we already dealt with all those things. This is a handy folder for basic date and times. Yeah. That's good. Save all the docs, all the links to the docs. Still taking a while for scikit-learn to install here. So we have this linear regression. Underfitting, overfitting. The great takeaways of linear algebra is that functions that don't seem linear can be made linear through transformation. And that's why like you get these regression, you can use different polynomials rather than just a straight line. Yeah. polynomial regression. It's interesting that they have that. We should probably go through that too. I need to like pause. I just need to figure out like what's the minimum I need to achieve here in order to feel good about applying my knowledge to get a job related to data. Really, it doesn't have to be something in depth with science, but it does have to, I just want to be just want to get in there. All right. So I guess we'll flesh out the outline here. I wonder if we have an outline for this. Oh, isn't there an outline? Could have sworn there was an outline. Here it is. Oh, it doesn't actually show all of this stuff. Maybe it's at the bottom. No. No, okay. Okay. Well, I'm just gonna write stuff here. We're gonna do a regression analysis, right? Regression analysis. Here we go. And then we need another one. Another markdown cell for then we're at communicating, which is a different thing, I guess. So they haven't actually gotten to that there. Communicate. Interesting. Okay. This is actually a pretty good demo to go over. Okay, so it's really taking a while for scikit-learn to install here. So I think what I'm going to do is maybe I'll just add another. Just want to test that it's working there. Get IPython going and see if I can import. It is there. So we can work with it. There's just something going on. Maybe it's not fully installed yet. So, but we should be able to start working on this and see if anything comes up. Okay, so we're going to import pandas as PD. So we already have pandas as PD. What we want to do is import matplotlib, pyplot as PLT, and then we want to read the CSV from there, right? It is equal to PD.read CSV. I mean, we don't have to because we already have it in there, but so what this is kind of doing, maybe we should do this in a different notebook. So you have one notebook to clean the data. Then you're doing another one to do the data analysis. And maybe another to communicate. I don't know. Of course, there is no file located there. Okay. So we need to create figure and access handles for the subplots here. Subplot comes straight from Long Beach. All comes back to you. Get what you deserve. Try and test that. You're bound to get served. And then do an ax.scatter, and then we're going to do data IMDb, get that series, and get the other series for Rotten Tomatoes, and we're going to try to see if there's any relationship there, I guess, with the scatter plot and that. So we can also set the title. Always a lot of stuff that you can work with here. You can get some quick, so the benefit really of matplotlib is that you can start exploring graphs without labeling them at first and without like going through all the motions of doing picking, what should the hues be, what's the color I'm going to use. It's just like for doing some quick and dirty visualizations to investigate the data sets. And it's interesting that even before we got our data set, even before we did any kind of visualization or plotting, did cleaning and all that. So it's kind of interesting. I don't know. I think that you usually do some visualization up front. I mean, I probably would. So there does seem to be pretty good relationship with these middling ones. The higher ones kind of diverge from that line, right? But it does look like they do go up there. I wish we could probably plot that between 0 and 10 just to make it visually kind of correct. I think we can do that, actually. I'm going to try to do that. I'm going to do AX dots. Set limits. Min. I think we can set the x limit as 0 to 10. There we go. It does, like, we can see it a lot better, but it does kind of, I think, give us a better idea of. There we go. They're a little closer together, but that's fine. We do see kind of where they are located, that they do have an average that is, above 5. Right, the order is arbitrary. We don't really need to know. We don't really need to have the IMDb or the average or the right domains. We're really just interested in the relationship, whether or not there is one. So to help readers understand your plot, you apply a title and then write sensible labels for both axes. Big Show, which is optional, and Jupyter Notebook may be needed to display your plot. Jupyter Notebooks, your plot should look like this, and scatter plot shows a distinct slope upwards from left to right. This means that as one set of ratings increases, the other set does as well, at least visually, right? To dig deeper and find a mathematical relationship that will allow you to estimate one set based on the other, you need to perform a regression analysis. This means that you need to expand your previous code as follows. Okay, linear model. So expand the previous code. Oh, I see. They're gonna expand on that, but I'm gonna. Okay, well, that's fine. It's fine. I'm gonna keep it as that though. So what I want to do is go up into here. Linear model, import linear regression. Right. We can do that. We get that. And what we're gonna do is change our x's and our y's, right? So what we're gonna do. So yeah, above this, I'm gonna do something else here. Data.loc. Slicing it. All of the rows from the certain column, right? From the column equal IMDb. And then the data for Y is going to be I guess they're doing this by two different versions, two different ways. I guess so. Okay. We can actually run that and go. IMDb and then Rotten Tomatoes for the other one. Oh. So they're both that, but yeah, it's so weird. One's a series and then one's a data frame. That's so odd. So let's go fit that. I don't know if that's going to work. Got to create a model, a linear regression model, right? And then we have to fit that model to the data. Is the data that we have is x and y. And then we're going to calculate our r squared, which is our correlation coefficient, I think, right? Or I think so. This is going to be the model for x, y, Okay. Then we're going to get a line of best fit, which is the coefs, right? And we're going to get the first coefficient for that too, up to 4 decimal places times model.intercept plus so plus 2. And then we're going to use that to predict, right? Y prediction. So model.predict, right? Okay. Now we can then lay over the top of that the X and Y or the Y prediction model, right? So by default, it uses ordinary least squares. Yeah, oh yeah. Okay, I didn't actually see any of that though. Did we print that out at all? Oh, interesting. Variables that's just a convention. You'd want to expose to your users as public attributes and have been estimated or learned from the data must always have a name ending with a trailing underscore. For example, the coefficients of some regression estimator would be stored in coef. Okay, let me do that then. It's been called so. Attributes that you learn in the process and you'd like to store yet not expose to the user should have a leading underscore intermediate coefs. You'd need to document the first group as attributes and no need to document the second group with a leading underscore introducing. Yeah, that's weird. That's interesting. So, I mean, yeah, it's a world to dive into there. All the little details there. Okay, so we're going to produce our scatter plot. So rather than doing it this way, what we're going to do, actually, what we should do maybe is move this one up. And then we'll try this again. So we'll do fig, max, creating the figure and axis handles from plt.subplots. We'll do a scatter plot, and then we'll do the plot of x, y, y pred, right? And we'll plot that on top of there, which is going to create a line. It's going to be a line, so you have your axis handle, and then you have graphs that you put on top. So you have data that you put on top. You have that scatter plot that goes on the axis handles, and then the plot goes on the axis handle as well. So you can have multiple axes. Is like what you can do, so that you can do multiple subfigures within the same figure. R squared. We're going to put our R squared there. So from, okay, so we're going to put it at the coordinate 7.25 to 5.5. Font size is going to be 10. And actually, what we're going to do, set all the same details for the title. And other stuff. So you notice you can annotate with the text. You can put text objects on top of the axis. There we go. And that's that. So we can also change the limits, right? X. Oh, like after we plot it, we change it X dot set xlim. Okay, well, maybe where we set stuff, so set title. Could even do it like this. Just doesn't come out as well, right? We can just like get rid of that. Looks better that way. Yeah, okay. Because the X values are coming from, right, and then it's just connecting the points with a line. And it's going to be a straight line in this case. Right. And there we go. That's how we can do this. So we have the... I must have... She's very happy with herself. Oh! That's weird. I don't understand why the... Oh, I think I understand. There must be some... Oh, no, there it goes. Oh, it was the line of best fit. It was too small. It was too far down. Okay, never mind. Here we go. And then we also didn't put an X at the end, I think. I guess the plus adds a plus or a minus. I think that's what that's doing. So we actually had an intercept that was positive. It would add a plus there. That's interesting to do. I guess it's signed format. Oh. That must be what it is. Okay. So now let's go investigate a statistical distribution here. And big X. And we're going to do the link here. Yeah. Value counts, but now we're going to do bins as 7 bins. Interesting. You can bin them that way. Ah, forgot that you could do that way. And you could do a bar graph or Instagram. AX is equal to AX. $5 is $5. Inflation has made that $15, I think. $15 is $15. This label, it's going to be time range in minutes. And the Y label is going to be count. So we're doing the film length distribution. We're going to bin it by into 7 different categories. So I'm interested in seeing how that divvies that up. So it's going to go from the minimum to the maximum. Then chop it up 6 cuts into making 7 bins. So let's see what that gives us here. There we go. Look at that film length distribution. This should really be a histogram. Should be a histogram. Plot it quickly using the series dot bar. Yeah, plot dot bar graph. You can also, it should do histogram though. Or like, can you change the gaps? Oh, with those things though. Well, that's not right. Oh, if it's 1, then is that like, there we go. And then we can just do a gap in between them. There we go. Tiny little gap in there. There we go. You see a tiny little gap. That looks a lot better, I think. Just put them closer together. Yeah, that's the way you want to do that. You can always control a whole bunch of stuff with Matplotlib. Lots of extensibility with your graphs there. Can also, like, because Seaborn is built on Matplotlib, you can get to the underlying Matplotlib figure axes and axis handle, or figure handle and axis handles, and you can modify them after you create something beautiful in Seaborn, and then you can like just tweak it a little bit. So that's the beautiful thing about Seaborn. Movie lengths resemble a normal distribution to some extent, sure. With right kurtosis, I think, right? Because it skews left. Skinny tail on the right. The mean movie time sits between, or like fat tail on the left. Mean movie time sits between 122 minutes and 130 minutes, a little over 2 hours. This doesn't really help me. Like, this visualization isn't broken up the way I would want it to be, right? I wouldn't choose these bin sizes. Very hard to examine these things. But by having it automatically do this, we do see that there is kind of a central tendency that, and like there's weak symmetry, not exactly symmetrical, but there is some symmetry. Okay, so we can also find more specific ones if we wish. We can data film length ag. So these are aggregate functions, right? We want to perform aggregate functions min, max, mean, and standard deviation. That's going to perform that on every single oh, I guess it's like it's going to perform that on the entire thing. Let's see. 106, 163 mean and that. So we can actually we could overlay this on top, right? Oops. I don't know what I'm doing. We are going nutty. There we go. Okay, I don't want that like that, but let's go with it anyway. We'll do that like that, and we'll just get rid of this here. So there we go. What happened here? Something happened. Something wrong with the YAML? No. Why is it not evaluating? Oh, shoot. What happened here? What the frig? Did I add like a... Oh, because find is up. There we go. There it is. Okay, that's so weird. Okay, because we did find. Never mind. Okay. What if we wanted to... Let's move this sucker up. Oops. Well, that's weird. How do I access each of these things, right? I can get this to a list, can I? There we go. Yeah, I can do that. We do time min. Time max. Well, obviously, time min and time max are already there, so we might not need to. Yeah, we're not going to need to show that. Time mean. Time standard deviation. Patient's getting sassy. Not what we want. Cannot assign to a literal. What do you mean can't assign to a literal? Oh, duh, of course. What am I doing? I need to make it variables. I don't know what even I'm doing. What even am I doing? What am I even doing? What am I even doing? I'm going to do a hex a line, maybe? A line, maybe? Or plot? Yeah, plot. Yeah, and then what do I need? What is it? Alt-Shift? Alt-Space? That's not it. And Control-Alt-Space? I don't know what I'm doing. What is the command? So we did plot, yeah, the line, and so it's the series and then that. So we need to put two things in each of them, right? So we need to put from the X, we need to go from like what 105, or we need to find where it is on the X. So it's going to be the same value for the X. So it's going to be the time mean and the time mean. And then it's going to be from 0 to, let's go to 8.2 or something like that. And then color is going to be red. Read. And then if I do that, that didn't work. What? Time mean. What are we doing? We have the X being from time mean to time mean. And then the oh. Oh, duh. Okay. Well, you have to find where it is in there then. Um, yeah. Yeah. What if we did it at 0, 0? Where's 0, 0 on this plot? That's over there. That's on the left. So in order to calculate this, it's a little funky, isn't it? Let's go back and let's calculate that line. So where is the location? So time mean location is going to be time mean x, or chord. Yeah, chords. Let's go with that. I'll have to calculate this twice. So we'll do time mean. We have to take the average, so if we normalize it between 0 and 1. So time mean divided by, yeah, divided by the difference or the sum, divided by the sum of could just do sum. That should get me the right thing. So that's the x value and then the y value. That's really just what we need. And then like I can float object is not iterable. Float object is not iterable. No, of course not. Need to do that on that. Okay. Yeah. Yeah, it's better. It's clear. Okay. So from that's weird. um where is it at 1, 1? Okay, well that's odd. 1, 1. How about 7, 7? Oh, it's by bins. You locate it by bin. Oh my gosh. And it's actually the seventh one is to the, okay. Well, that's weird because 1, 2. Oh, there's 8. There's 8 locators. So the 0 is at the left of the first bin, and then the 1 is at the right edge of the first bin. Okay, so that's interesting. We're learning some stuff here today. So what I so all I have to do is just multiply this by 7, I think, or by 8, and then that doesn't seem right. Because the mean, what they say the mean was between 122, so it should be over here. Should be over there. So if I multiply it by 7, it still seems wrong. Why would it be? Can't just be 6. Like that doesn't even make sense. How do you even do that? Huh. How do I even do that? There's 8 total bins. So you're going from 0 up to 7. Should be divided by 7. So 7. So to get the center, the That is the midpoint value, right? I wonder if we can get the median. No. Mm. We just call it the median. There we go. If I can like figure this out, then we can like abstract this into a function and reuse this. Okay. Hmm. Hmm. That should be the midpoint, right? So the oh, I'm not normalizing it correctly. Okay. Right, of course. I was thinking you have to do mean minus the min value minus the minimum, right? And then the sum. Well, no, you want the difference. Okay. Then you want the difference. There we go. That's it. That's how we normalize between 0 and 1. Okay. Wow. GPT-4 it actually gave me the right thing. Value minus minus. So where does that come from, though? Nifty. Nifty, nifty. Normalize that data point. We need to normalize that for this. So we can also do the same thing for the median. I guess I'll just do that. X chord for that, and then we can plot that, right? We can plot that, and we can do the same thing there. And we can do and then let's do green or black. Let's do black. The median is the mean? That's interesting. It's not, because I did that wrong. There we go. The mean is slightly shifted to the right, right? Slightly to the right. There we go. Mean and median. There we go. And then what else can we put? We can put the standard deviation, so we could put like one standard deviation away, right? And you can put our standard deviations away from there. Oh boy, that's another project. It's already too late in the day. We gotta get down. We gotta just finish this up. This is too much of a rabbit hole to jump down. Too much fun stuff. Too much fun stuff to be diving into here. So I plotted the median and the mean as lines on there. So we could label that as well. Okay. And then how would we do that? So we need the X coordinate and the Y coordinate, I think. X float, Y float, and then the string, there's the text. So we need the coordinates. So the coordinate we need is the time mean X coord, and then the Y coordinate we can just put like, actually, can we just put like, yeah, okay. I think I have an idea. Let's put it at 7. And then we'll just add a little nudge to the right of it. And then I think what we'll do is to put it, is there like an alignment? You can change the font size. Let's just see what we can do here. Yeah. The mean is 128.2, and then we can do, so I like that. I just wonder, oh gosh, can we do a background? Let's put it up above at like 8.1. Beautiful, beautiful, beautiful. And now we can do the median coordinate. We want to do minus, but then like line right, text alignment. Horizontal alignment right. Okay, so we want, and then we'll put this at 6, and then I'll do the string as the median. Yeah. Yep, there we go. Okay, 0f. I can't think you can also do it as integer, right? I guess 0f works. So that does do the alignment to the right spot. That's a handy thing to work with, is the text. Okay, that works. Beautiful, beautiful, beautiful. Okay, I think if we just do it as that. Yeah. That's fine. I guess we could like move it up. 8.1. That looks pretty cool. And then what you can do is like just put this on the other side so that you have it like kind of juxtaposed. There we go. Yeah. The mean is there. It doesn't look right though. It looks kind of stupid. Okay. Or you can fiddle around with it. Like, you can always fiddle around with this. Text alignment, align the plot. Okay. Okay, so I think I'm just going to wrap it up here. So we have to go through finding no relationship. So let's go through that, and let's go fig x PLT subplots. Scatter data MDP bond kills. Okay, so the rating versus that. I wonder if the gross, if any of the money that's made does that. I probably have us do that as a exercise here. Maybe here, you're going to get a very weak correlation there. You can also plot some other things as well. It's a gun, isn't it? Yeah. Bond movie fans don't seem to care much about the number of bad guys that Bond eliminates while analyzing data. It's important to realize that you may not always find something useful. Indeed, one of the pitfalls that you must avoid when performing data analysis is introducing your own bias into your data before analyzing it and then using it to justify your preconceived conclusions. Sometimes there's simply nothing to conclude. At this point, you're happy with your findings. It's time to communicate them back to the bosses, right? We need to do a course on like reporting. I really do need to look at that. So, let's do that next week or this month. Probably be at the end of the month or something. Reading that Bill Frank's book will definitely help as well. Yeah, just gonna do that. Okay. Could do this using a report or presentation. Okay. Issues will come up that require future analysis. Once more, you may need to set additional objectives at work. So we could even we could examine some of the other relationships between the other variables, especially like the bonds, the number of bond kills versus the box office thing. Although it's hard for that. There's definitely there would be though there might be a correlation. There's absolutely no way to prove the causation there. There's how did you know going in that he was going to kill so many people? Right. So I guess some things make sense, but some others don't. Gotta always just be critical, minded, and think about what got there. Okay, so this is an interesting notebook that we created for this this module. Trying to think if I should publish these on GitHub. They're kind of messy. I want to make them at least clean. I don't want to put that. Definitely not putting this one into a portfolio. It's not fleshed out enough with the wording. There's not enough commentary on it for me to put it up there. Yeah. Might write some scripts and read future versions of the data, cleanse it, and analyze it in the same way that you just have. So allow future results to be compared to yours and will add scalability to your efforts by repeating your analysis in the future. You can monitor your original findings to see how well they stand up in the face of future data. Alternatively, you may discover a flaw in your methodology and need to reanalyze your data differently. Again, the workflow diagram, right? Okay, so there was actually they gave us some crap data anyway. So there were some errors in the data set. So apparently, Never Say Never Again was another movie that's not considered a part of the James Bond franchise. However, it did star Sean Connery. So then technically both Connery and Roger Moore, have played Bond 7 times each, or 007. That's it. M is very pleased. As your reward, he instructs Q to give you a pen that turns into a helicopter. Always a handy tool to have for tracking down future data for analysis. You've gained experience in using a data analysis workflow to analyze some data and draw conclusions from your findings. You understand the main stages in a data analysis workflow and the reasons for following them. As you learn more in advanced analysis techniques in the future, you can still use the key skills that you learned here to make sure your future data analysis projects progress thoroughly and efficiently. Okay, cool. This was really good. Very well thought out. I'm going to say that. Blubbity blue. I can't, like, my brain is fried now, so I can't even remember what it was where I stopped and I was like, oh yeah, that's a good point. Saving the data, cleaning the data. Yeah. Cool. Okay, so what's my number one takeaway? Um, you said, um, yep, I'm almost done. Um, oh gosh, interesting thing on bias. So bias did come up. We're just gonna add that. You know what? No, I'm not gonna add it. We'll come across it again. Bias of an estimator and all that. Yeah, this is a really good article, a really good tutorial module. Um, great exercise. Yeah, that's gonna do it for today. We are going to close this up. Get our Obsidian back up here, do a little bit of review here, and see what we can take into tomorrow. So, do need to check on my calendar. So I do need to move the exploratory data analysis over to that tomorrow, and then maybe I'll just move the conditional things. I don't know. Should we do that? It is going to be important to do that. Maybe I'll do that on Monday. I did have like a gap there intentionally. So tomorrow we'll do exploratory data analysis with the book Practical Statistics. Finally start that. Then we'll go and carry that into Friday, do the weekly review. Tomorrow's Khan Academy going to be a repeat of the geometric distribution, which I'm just like we made a note for that, right? We made a note for that. We got the key stuff that I need to take with me for that, and how to do it with SciPy, right? And we have the methods for SciPy, getting the mean and the standard deviation. So we'll just use this. We'll just use this library, get used to it. So exploring the geometric distribution through SciPy, basically. What else do I want to say? So let's take a look at the notes that we created today. I'm going to actually put this over here. and then go to my other note here. What happened here? Why did it like... Okay, so weird. Notes created today, why use assign rather than that, and then there's the geometric distribution. We also did flesh out our data analysis thing there. Data analysis workflow we referenced. What else did we reference? I don't remember. Been a long day. Okay, I'm done. So we'll be back tomorrow, and